Hello and welcome back to my channel. Today we're going to be going over the wrong answers that I gave on the MAT 2021 paper that I sat on November the 3rd, along with 5,000 other candidates worldwide. So, and these are the multiple choice ones that I got wrong. I don't know quite if I got all the long answers wrong. I know I got parts of them wrong, but I don't know the exact answers, whereas multiple choice, it's explicit. I got it wrong or I didn't. So we're going to be looking at questions D and questions G. So question D. We want to find the area of the region bounded by the curve y equals x and the curve y equals 1 minus e to the x. Y equals e to the x and the curve y equals 1 minus e to the x and the y-axis. Now, I was a bit thrown in the exam. I overcomplicated and I thought, well, if it's bound to the y-axis, I'm used to things being bound to the x-axis. And I thought, I'm going to have to rotate it, which was much, much more difficult than it needed to be. So what I'm going to do is the proper method now. Okay. First of all, I'm kind of thinking I want to find an intersection point between y equals e to the x and y equals 1 minus e to the x. Because if it's bounded by those two curves, it must be between those the intersection point. So e to the x equals 1 minus e to the x. Therefore, 2e to the x is equal to 1. E to the x is equal to a half. Therefore, x is equal to natural log a half or minus natural log 2. We will be using both of those when we do our integral. And if you look at the picture of the curve, I'm just going to do a brief sketch here. It does something like this. So it comes up, there's e to the x, and then 1 minus e to the x comes down here, and we're trying to find this region here. This is the point minus natural log 2, and we're looking for the integral of between minus natural log 2 and 0 of 2x minus, e to the x minus 1 minus e to the x, which is the same as writing 2e to the x minus 1 dx. And that's going to be equal to 2e to the x integrates to 2e to the x minus x is the minus 1 integrates to minus x between minus natural log 2 and 0. And plugging in the limits, so 2e to the 0 is just 2 minus, the minus x just goes to 0 because if you sub in 0 for x, you get 0. Minus our second bracket. This is where we've got to use our natural log of a half rather than minus natural log 2. So 2e to the natural log 1 half, the natural log and the e cancel, and it's just a half times 2, which is 1. So we've got 2 minus 1 at the moment, minus natural log 2. So a minus changes to a plus, so I'm going to say it's plus that in the bracket. And that's just going to be 2 minus 1, which is 1, minus natural log 2, which is answer B. And then the next one, question G, is this sum of sine squared terms. I really was stumped when I first saw this, but it was my favourite question. Even though I got it wrong, it was my favourite question because it helped me rethink how to do arithmetic sums. The first thing that popped out to me in the exam, I just didn't work it out correctly. The first thing that popped out to me was that I know what sine squared 90 is. That's just 1. And I know what sine squared 45 is. And that's just going to be a half, because it's going to be the square of 1 over root 2. And so it's going to be squared to be a half. So I've got to have something with a half in my answer. So it can't be A, can't be C, and it can't be E. And what I wrongly thought in the exam was that sine squared 1 is going to be smaller than sine 1, and sine squared 89 is going to be smaller than sine 89, and therefore it must be 44.5. But that's not the case, which I will show now. Now, if you remember that sine x is equal to cos 90 minus x, you can get sum of sine squared plus cos squared terms. So that means that sine squared 1 degree is equal to sine cos squared 89 degrees, which means we have a sum of we have sine squared 89 degrees plus cos squared 89 degrees, the Pythagorean formula for trigonometric functions, which is 1. And this will happen if you divide 90 by 2, because we've got 90 terms, you get 45. And if we minus one pair, because we've got the 45 and the 90, that's one pair. That's going to be 44 pairs of just 1, because we worked that out here. And we're going to then add 1 for the sine squared 90, and then add 1/2. And that gives us 45.5, which is answer D. Thank you very much for attending this video, and I look forward to seeing you all next time.